Hello, here's Miss Walsh, and today we're going to do day 2 of Voronoi diagrams. We're going to construct them. So just some quick vocabulary. Remember that each one of these are called sites, and the boundaries that split the distance between the sites in two, those are called cells. Those are called edges, and then all of the region that is on one side of the boundary is then called site. So let's look at how we actually construct them. What's important is that these edges, the boundaries, they're always perpendicular bisectors, okay? To find perpendicular bisector, you always have to find the midpoint between the two sides that you want to split up, and then you want to go perpendicular slope then between these two. Okay, we're going to see this in action. So these are the formulas that will be of use. Remember your wonderful slope formula. The distance will come a little bit later. And then, of course, this is the midpoint, which is just the average between the x's and the y's, okay? All right, so there's four fire stations, A, B, C, D in town. That's the coordinates. So in order to improve the response, they've installed a new centralized fire system. Okay, so what we need to do, you can read the rest of this, is we need to create a Voronoi. We need to split all this in half. Okay, so we're going to go step by step, and they're having us start with constructing the perpendicular bisector of AB. Okay, so there's AB. So if I wanted to connect it, it would look like this. The vertical ones are actually super easy because the perpendicular bisector was just going to be a horizontal line. It's going to go in the middle. Be careful, the grid here is going by 0.5, not 1. Pay attention to the scale. So between 0 and 4, in the middle is just 2. So this is just going to be a horizontal line like this, okay? So we're going to call this L1. Ta-da! Okay, so now the second thing they're asking for is now we have to split AD, okay? So what do? First thing is find the midpoint of AD, okay? Now you can either use the formula that's always there, or you can just do it by inspection, right? So if you wanted to, you could do like, okay, this is 1, 2, 3, so it's going to be in the middle here, and this is 1, 2, so it's going to be here, okay? You can just see that. Good. So what is this? This is then 2.5. So this is the point that the perpendicular bisector is going to go through, okay? So this is 2.5, and this is 3.5. Second thing, we're going to find the slope of AD. And again, instead of the formula, I'm just going to look. This is going 1 up, 1, 2, 3 to the left. So that means that it has a slope of negative 1/3. And so then your perpendicular slope, or the slope of the perpendicular bisector, is going to be, remember, flip and switch the sign, negative reciprocal is going to be 3. Okay, so if you needed to construct the equation of this line, you can now do that, good old mx plus b, but we don't need to do that, okay? We just need to go with a slope of 3 up, so 1, 2, 3, and then 1 to the right, or you can go 1, 2, 3, and 1 to the left. Remember, that doesn't matter, down and left is the same thing. And I'm actually just going to be super neat, which is not really my specialty, and I'm going to just create a line like this, okay? You don't need to extend it further, so always stop where it meets the next boundary, okay? So this is the first part of our Voronoi, woohoo. Okay, so this is L2. Okay, so next thing, we are going to have to split D and C. So again, let's start the same process again. So first, we're going to do the midpoint. And you know what, just for fun, you can see that D, I'll use the formula, okay? So this is 4 and 3, and this is 5 and 1. And so then 4 and 5 over 2. And then 3 and 1 over 2. And then this is going to be 4.5. And again, you don't have to use the formula, yeah? So this is 4.5, and this is 2, right? So just check. Does that work? So 4.5 and 2? Yeah, sure. You can see that that's the midpoint. Okay, second step, we're going to find the slope. So the slope of CD the slope of CD is going to be 1, 2, and 1 to the left, so that slope is negative 2, okay? And then we're going to find the perpendicular slope of the bisector, and that's going to be positive, and it's going to be 1 over 2, because any 2 yes, whatever. Okay, so then 1 up, 2 over. The fact that I'm going up by half and not a whole thing doesn't matter. 1 up and 2 over, so then 1 down and 2 over, like this, okay? And so then this is the line, and that's it. This is your new edge, okay? How far are we gonna drag this? Again, I'm just gonna drag this like long just to show you that it doesn't matter. And then what we're gonna do is we're gonna shorten it after, okay? So what we've done though is we have, this is our L3. What does this mean in context, by the way? What this means is that, you know, if you live somewhere here, the closest fire station to you is going to be station D. If you live somewhere here, the closest fire station to you is going to be C, okay? All right, so next job. Boom, done. Doom, doom, doom. All right, let's go green. So now we're going to do the same thing with BC. And again, feel free to pause it. So this is at 1, this is at 5, so it's going to be at 3. So this is going to be the midpoint. I hope that's okay. Midpoint. I'm just rushing this a little bit so the video is not too long. So this is going to be 1, 1, 2, 3, 4. So right now, the slope of BC is 1 over 4, okay? Therefore, the perpendicular slope is going to be -4. So we got to go -4. This doesn't go down, so go up instead, but then just go to the left. Yes, because it's a negative slope. So 1, 2, 3, 4, and then 1 to the left. So this is what the line is going to look like. Again, I'm going to insert a line. You just connect it with your ruler, okay? So how far do you go? Okay, this is too far because remember, you're going to want to stop as soon as it meets that other boundary, okay? Like this, okay? And then same with this line. They're just going to make a nice little intersection. Okay, so now these two, that's kind of weird. You just connect them. Okay, and that's it. So again, these are your cells. So if you live anywhere closer here, then you are closest to A. If you live right on the line, you're equidistant from 2 fire stations, so I guess you're lucky. Okay, label the intersection of L1 and L2. By the way, this is L4, Miss Walsh. Okay, so L1 and L2, that's right here. So let's label this point E. What does this represent in context? Okay, what this represents in context is that you're actually here, because this is D's on this boundary, and then A and D and B are like all relevant to this. What this means at the point of intersection is you're actually equidistant, okay? So at E, we are equidistant from, can you say which one? Ha ha ha. So A, B, and D, okay? And then similar to this one, we're going to label this F, okay? And so then F, that one, is equidistant from, so which one is that relevant to? So D and C, C and B, and then this, of course, is then the split between B and D, okay? So then this is equidistant from D, C, and B, okay? So, good. Okay, sometimes we draw the edges by terminating their equations. Sometimes we draw them by visually. Be comfortable with both. Yes, what I can do very quickly is just find the equation, because you are going to have to find the equation. Let's just find the equation of L2. Okay, you know how to do this. It's just, boom, time to go home. Good, so it's y equals mx plus b. You know your slope. Remember, the slope was 3. And you know your point. That's always that midpoint. So if you need to find an equation, then just sub it in. And you can use that other form as well, by the way. That doesn't matter. So 7.5, and then this is 3.5, subtract, and you get b is equal to -4. And so your equation to this line is 3x minus 4. The y-intercept doesn't have any contextual meaning to us, but you can see if you extend it down, it would land somewhere there. But you are going to need the equations of the lines, because at some point they're going to ask you to find these intersections. And that might be algebraically. Remember, yeah, we use linear solver, and for that you will need to build these equations, okay? So there you go. These are our beautiful Voronoi. Thanks. That's it.